All right, Tuesday is one of my favorite days of the week, and that's because I'm joined by Dr. V for another cool experiment to explain science. And Dr. V, what do we got going today? You got some, bouncy balls here.
It's a really fun experiment.
Yeah, what do you got here?
Basically what you have here, maybe you can, when you zoom in, you can see that I have two balls.
Two balls.
So it's just the regular rubber ball.
Right.
Okay, so I'll give you one.
Okay, cool.
And I'll hold on to one.
Gotcha.
Okay, so I'm going to bounce. So normally kids would bounce the ball, right? See?
There you go,
it just bounces.
Very, very
now
cool.
You go ahead and you try yours.
All right, cool. Wait a minute. Wait a minute. What's wrong with my? It's not. Okay.
You're doing something wrong.
I guess my technique is wrong. I'm actually trying to throw it down here, and it's not even bouncing. What's going on, Dr. V?
Let's do it together.
Okay.
Maybe something happens.
Okay, so it's not just me here. So
okay.
What's going on right here?
So the one that you have, so this is actually, it feels, go ahead.
They feel exactly the same.
Pretty much the same, and unless you bounce it, you won't know which is what.
Right,
okay?
exactly.
So basically how they made and the polymer, it's basically polymer. So the polymer in this case, it's called, so the bouncy ball, it's called neoprene.
Okay.
Which is sort of the regular natural rubber.
Okay,
and
neoprene.
in this case, it's actually polynorbornene, and which is a different polymer.
And literally, it is not bouncing at all when you drop it on the ground.
It's not bouncing
but it feels
at all.
the same. And so what's the story?
Technically, it's called coefficient of restitution, which is like it can come back to its original shape and size. It remembers its shape and size, but this one doesn't. Okay, and actually, it has to go back to the glass transition temperature. For any polymer, we call it glass transition temperature.
Okay.
So basically, at about minus 42 degrees Celsius, above minus 42 degrees Celsius, this rubber acts like rubber. It's very elastic.
Oh.
And for this one, this is 35 degrees Celsius, which means that above that temperature, it always acts like this.
So does it matter if I put that regular rubber ball maybe into a freezer or something like that?
Actually, if you put it in, let's say if you put it in liquid nitrogen, and then just freeze it, it would behave totally different.
Oh,
it would almost behave like this.
Oh, okay.
Now, on this case, the hard one, if you boil it, if you actually boil it, you would actually bounce to about 1/3 of this.
Really? So temperature makes a big difference there?
Big difference.
Oh, very cool. Well, Dr. V, thank you for telling me this. And again, I'm going to probably play a little trick on Steve and ask him to try bounce this later.
Go ahead.
We're going to have all the information online. And again, very, very, very cool. I'm going to try play with this a little bit more. Again, thank you, Dr. V, for coming in and explaining this to us.
Thank you.
All right, Dan, you got to check this out later. Over to you.